All right, this is on the topic of transformations, reflections. So a reflection is a flip over a line called the line of reflection. So we used a slide to describe translations, and we use flip to kind of help you understand what a reflection is. Each point in its image are the same distance I can spell from the line of reflection. A reflection is also an example of rigid motion. We talked about that in translations. The only thing that changes is location, not size or angle. So remember, the image is where we end. So if we look at the diagram to the left, triangle ABC is our image or pre-image, and triangle A prime, B prime, C prime is our image. So when we reflect things, there's a couple of common lines that we use when we go through this. We use the x-axis, which is the pink line. We use the y-axis, which is the vertical yellow line. Sometimes we use vertical or horizontal lines in the form of x equals some number or y equals some number. So like we could do x equals -5. Sorry, that's y equals -5. I am the math teacher. Y equals -5, or x equals -5. We also can use diagonal lines, like y equals x, which looks like that, except maybe a little straighter. So that's y equals x, where 1, 1, 2, 2, 3, 3, the numbers are the same. Or we could do y equals -x. So that line just goes the other way. And this is y equals -x. So those lines, the pink, yellow, blue, and green, are common lines of reflection that we use. We can do other ones, but we try to make them a little less ugly. So when we reflect across the x and y axis, we're going to graph and label each figure and its image. Remember that the first figure is the pre-image, the image is where we end, and we're going to do it across the x and y axis. So first we start by plotting our triangle. -1, 2, 3, 4, 2. That's A. B is for 7, and C is 5, 1. So here's our original triangle. This is our pre-image. I can get this maybe here, close enough. So there it is. And we're going to reflect it over the x-axis. So I'm going to highlight the x-axis. So remember that every point has to be equal distance from that. So when we start this, since C is 1 here, it's a distance of 1, then it's going to be a distance of 1 here, and that will be C prime. B is 7 up, so we find this line and we come down here, because this is the line that B is on, and we're just going to count down 7. So that's B prime. And then A is 2 up, so then we come 2 down, and here is A prime. So when we connect our dots, there's our triangle. There's our reflection. So we have -4, -2 for A. C is 5, -1. And B is 4, -7. Notice in each coordinate that the x-coordinate stays the same. And when we look at the c-coordinate, notice that it changes signs. So that's for the x-axis. Now let's look at doing it over the y-axis. What's going to change? So we do a rectangle, 1, 2, that's P. Q is 2, 5. R is 8, 3. And S is 7, 0. So connect our dots. Remember to use a straight edge. I get to cheat because I have point finder. So there's my original one. Now watch how, because here's our y-axis, watch how the coordinates change. So it has to be equal distance. So P has to go over 1 right here. But notice that it's still up 2. So now it's -1, 2. Look at what changed. This time, the x-coordinate changes. So then we'll go through and graph the other ones. So this is P prime. Q is over 2, so we go over 2 here to get Q. That's R and S prime. Okay? So R becomes -8. Shh. Shh.
That's just cheese.
So -7, 0 and -2, 5. So again, what changes is the x-coordinates, because the y's all stayed the same. But our x's just change signs. So that's how we do x and y. So I'm going to give you the opportunity to do the other two and verify. So for the y-axis, x opposite sign, and for the x-axis, y has the opposite sign. All right, let's look at when we do some other horizontal and vertical lines. So we're going to do x equals, for number 5, x is 4. So x is 4 is every place that x is 4. So to get to the line that I'm drawing, you have to go right 4 every time. So that's my line. So let's go ahead and plot our original triangle. 1, -1 is J. Over 2 up 3 is K, and L is 3, -2. So there is our original triangle. So now when we reflect it, it just needs to be equal distance. So this is 1, this is 3, and this is 2. So this is L prime, J prime L, K prime.
To begin with, we need to review and
So let's look at what changes in our coordinates. So since we're reflecting around across the x equals 4, j becomes 7, -1. L is 5, -2, and 6, 3 is the other one. So I can get those coordinates simply by counting 1, 2, 3, 4, 5, 1, 2 down. And remember that it's just because it's equal distance here. Or if I take the original coordinates for L and I just added 1, because that's how far it is from 3 to 4. And K, how far is it from 2 over 2? So this is from here, it's +2, so then I had to add +2, and 1 to get to, I just lost it, to get to right here, that's +3, so 4 + 3 is 7. And then notice, again, that all of my y coordinates stayed the same, because I'm just moving it over. Nothing flipped about it when I did it that way. So I can do the next one because that's also an x equals line. Now let's go look at a y equals line. So y equals 2. Every way to get to this line is to go up 2. So that's y equals 2. So that's where my reflection is. So I'm going to do -4, 4, that's C. -2, 0 is D. Did I call the other one primes? I did, okay. E is 6, 1. 2, 3, 4, 1, 2, 3. And that's F. So then again, we connect. The points, and now we just count. So this is 2 from my line, 1 from my line, 5, and 6. I just need to make sure that all of my new points fit the same pattern. So we'll say that D goes right here. Oops, not there. Here, 2 up. So that's D prime. C is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is C prime. E is 1, so we go 1, E prime. And F, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's F prime. So, again, the easiest thing is to, once you remember that it has to be equal distance across, just count. Name your points by counting. This is 1, 2, 3, 4, 5, 6, 1. Instead of 6, -1, so that's E, 6, 1. Sorry, 3. It's 1 above, but it's 3 total from the axis. C is -4, 8. D is -2, 4. And F is 4, 7. Again, look at what stays the same. -4, -2, 6, and 4. -4, -2, 6, and 4. And the other coordinates, let's take the last coordinate and add to it. Alright, now we're going to look at some y equals x and y equals -x. So So for number 9, we got y equals x. So y equals x just means that every place, whatever, so x is, let me change this. X is 0, y is 0. X is 1, y is 1. 2, 2, 3, 3, 4, 4. You get the idea. It goes right through there. Then the same thing going the other direction. This is the line y equals x. So now I'm going to reflect something across that. So we start with -5, 2, and that's x, -3, +4, that's y, and z is -1, 1. So now when I reflect it, I just got to figure out how far that line is. So x is, so notice that we go down 1, right 1. So then from there, I'm going to go down 1, down 1, right 1. So then I go down 1, right 1. Why does it keep doing that? Down 1, right 1. And that is z prime. So what's the name of that point? Z prime is now 1, -1. Look at the coordinates. What happened? They switched. Let's see if that pattern continues. Remember that what we're learning in math mostly is about recognizing patterns and applying the same pattern to new situations. So z is down 1, right 2. So then down 1, right 2. Sorry, that's x. Should be x prime, which is did I not go down far enough? One, 2. How come it didn't go down enough? X should be -2, -5, because the coordinates flip. -2, 1, 2, 3, 4. Aha. Down 2, right 1. Goodness. So there's x prime. And then y is 1, 2, 3, 4, 5, 6 over 1. So then we go down 1, 1, 2, 3, 4, 5, 6. So that we can get y prime. See? And now those two shapes are equal distance, which gives us 4, -3. So when we're doing y equals lines, coordinates flip. Let's go look at y equals -x. See what kind of pattern we can see for this. Y equals -x is a similar thing. It goes diagonal through the graph. Whatever y is, x is the same number but the opposite sign. So -1, 1, 2, 3. There's A. B is 0, 6. C is 3, 5. And D is 2, 2. Okay, so I want that reflected across the same line. So let's see if we hold our theory 2, and we're just going to switch the points. So 2, 2 this is going to be slightly different because our x is negative. So this time, they change place and they change signs because a becomes negative 3, 1. So negative 3 up 1 is a prime. Notice that that's over 2, and this is over 2. C is negative 5, negative 3. Again, the coordinates change places and change signs. This was negative, now it's positive. This was positive, now it's negative. B was 0, 6, so it should be negative 6, 0. So I didn't actually graph C. Negative 1, 2, 3, 4, 5, 1, 2, 3. Here's C. Is that right? 1, 2, 3, 4, 5, 1, 2, 3. Yeah, C. D should be negative 6, or sorry, B, 1, 2, 3, 4, 5, 6, 0. That should be B prime. So far it looks like we're reflecting. And D, the numbers don't need to change, but both the signs do. So negative 2, negative 2. It's D prime. And if you look, those look reflected across. These are equal distance, those are equal distance. You can see that that's equal distance. All right, so what happens when I ask you to identify the line of reflection? The hint is that sometimes it's just easy to find the midpoint of the corresponding points. So corresponding in this case would be J and J. What's in the middle of those points? Let's just pick something and see if we can make it work. So that's in the middle. M and M prime are both 8, so we go back to 0. K are both positive and negative 3, and L positive and negative 5. So obviously, as we look at this, the line of reflection is the y-axis. Now let's look at this one. Remember that we're mirroring this. So this is where we started, and we put a mirror someplace to get that there. So obviously, it's a line that goes like this somehow. We just got to figure out where it is. So since we've only talked about, for diagonals, y equals x and y equals negative x, let's see if y equals negative x holds our pattern. So this is y equals negative x. So this is down 2 over 2. And this is over 2 up 2. Looks like it's going to. This is down 1, 2, 3, 4, 5, 6, 7, 8, 9. This is over 1, 2, 3, 4, 5, 6, 7, 8, 9. C. Down 11 over 11. So that's how I can see that that's y equals x. Number 15 should be kind of obvious. I'm reflecting this, not rotating. So what's in the middle between r and r prime? Now here's the only tricky part about this. Vertical lines are x equals, because we count x equals 3. So x equals lines are just odd because they look like they should be y lines because they're vertical. Let's look at 16. 16 is weird because the shapes overlap. We haven't had that before. But when you look at it, again, if I find the midpoint, and there they intersect, and the middle between U and U is here, and V is here, this is the x-axis. What's in the middle between y and y? When you look in a mirror, you are equal distance from the mirror, unless you're looking at a two-way mirror. Just go ask TikTok. 1, 2, 3, 4, 5, 6. So halfway would be 3. And z is the same, so halfway would be 3. It has to be equal distance and a straight line, so that means that this has to be the line that we're reflecting across. And this is y equals 1, because we go y equals 1 each of these points. It doesn't matter what x is, but every time I move, I'm going up 1. All right, the last one. Most certainly that's y equals x, but let's verify just to make sure. Because y equals x is this line. Hopefully that's quasi-straight. So that's y equals x. Again, 3 here and 3 here. F, 1, 2, 3, 4, 5. F, 1, 2, 3, 4, 5. So again, as we go through and check, all the points are equal. And that is how we reflect lines and shapes in the coordinate plane.